All right, problem number 2. This is all terminology, but if A is a subset of B, then which is true? And I wrote out, these examples here, but, A and B can be absolutely anything. We're just trying to make it a little more concrete by having a real example here. So A, in this case, is a set of 2 and 3. B is 1, 2, 3, 4. C is 1, 2, 3, 4. And the definition of being a subset means that for A to be a subset of B, every single element in A must also be in B. And we can see that, yes, this is a subset. A is a subset of B. So we can write that as A is a subset of B. And that's not a C, it's more of a sideways U. But by that same definition, where we say, C is a subset of B, if every single element in C is also found in B, well, that is a subset. Even though these things are equal to each other, C is equal to B, it is by definition of a subset. So they actually have a different notation for that. We would say that C is a subset of B, and B is a subset of C. And you can think of it as, like the less than or equal to sign. This equal to is just that bar underneath. But whenever you add the condition that set 1 is a subset of set 2, and you have the condition that set 2 is a subset of set 1, well, that just means that they're equal. And we can see that pretty clearly in this example. B and C are the same thing. But now looking at our options here to pick from, B is a proper subset of A. Well, think about it. B cannot be a proper subset of A because A is a subset of B. If B is a proper subset of A, then what that means is that there is some element that is in A that is not in B. But if there's an element in A that is not in B, then that means that A cannot be a subset of B. Now looking at our other options, A is a proper subset of B. Well, it could be, but we don't know that for a fact, and kind of the problem here is that we're asserting that this is true. B is a subset of A, and we don't know that for a fact. What we do know is that if we had the condition that if A is a subset of B, and B is also a subset of A, then that would mean that A and B are equal. And that is possible. If B is 2 and 3 and A is 2 and 3, then this and this could be true. But the fact is we're asserting that it's true, and we don't know that. So the only possible answer is D. A could be a proper subset of B. And that's true. We don't know. In this case, A is a proper subset of B. But it's also possible that A could be 1, 2, 3, 4, just like C. And if that was the case, then it wouldn't be a proper subset. So all we know is that maybe not, but it could be a proper subset of B.